Question number 23. Which alcohol could not be produced by the reduction of an aldehyde or a ketone? There's a quick way of doing this. If there's a methyl group at carbon number 2 and there's an ol group at carbon number 2, in other words, those two numbers are the same, where there's a methyl, the ol group, and there's a methyl group also at the same number. So 1 ol, is there a methyl group at number 1? No. 2 ol, is there a methyl group at carbon number 2? Yes, that cannot happen. 2 ol, there's no methyl group at number 2. Pentan 3 ol, no methyl group at number 3. So when you have a methyl group at carbon number 2 and an ol group on the same number, carbon number 2, that cannot happen. It cannot happen because what would it have been? It would have been the ol before it was an ol and reduced. It would have been a carbon to oxygen double bond at carbon number 2. So carbon number 2 would have had a carbon to oxygen double bond. At carbon number 2 there would have been a methyl group at carbon number 1, an ethyl group then at carbons number 2 and 3, and a methyl group. That carbon at carbon number 2 in the middle of a chain would have had carbons either side, a methyl group and a carbon to oxygen double bond. It would have had 5 bonds, impossible at carbon number 2. So the quick way of looking at it is, if those two numbers are the same, the methyl group and the ol group, it can't have come from a ketone. Which compound does not show stereoisomerism? So let's draw them out. 1,2-dichloropropene, 1,2-dichloropropane, 1,3-dichloropropene, and 1,3-dichloropropane. Which one does not show stereoisomerism? Well, remember, there's two kinds of stereoisomerism. There's geometrical isomerism, where either side of the double bond you have two groups. So I've got 1, 2, two different groups to the left of the double bond, two different groups to the right of the double bond, so that will show stereoisomerism. It will show EZ isomerism or geometrical isomerism. The CLs have larger atomic numbers, so this one's down and this one's up. This would be E1,2-dichloropropene. This one's got a chiral carbon here, so this can have optical isomerism, a form of stereoisomerism called optical isomerism, because this one's a chiral carbon with a Cl, an H, a CH3 and a CH2Cl, so that will have enantiomers. This one, to the left of the double bond I've got a Cl and an H, two different groups, and to the right of the double bond I've got an H and a CH2Cl. This one is going to form geometrical isomerism. So what have I got? I've got to the left of the double bond I've got a Cl with a larger atomic number than the H, so this Cl takes priority over the H, and to the right of the double bond I've got a C bonded to the C with an atomic number 6, H bonded with an atomic number 1. This group here would take priority, so I've got two groups on the same side. I've got Z1,3-dichloropropene. Whereas this one doesn't have a chiral carbon at all. I've got a C with two H's, I've got a C with two H's, and I've got a C with two H's, and no double bond, so no free rotation, no lack of free rotation around the double bond, no double bond, no geometrical isomerism, and no chiral carbon to give an optical isomer. So your answer is 1,3-dichloropropane. The answer is D. 25. Which compound can form a polymer without needing another reagent? So what I'm looking at is I'm looking at two different groups on either end. If I've got two groups the same, then they'll never bond and have a condensation reaction. So I need two different groups, one at one end which will bond with a different group at the other end. So I've got two ols here, a diol, and I've got a dioic acid here. So A and B are immediately ruled out. C and D has got an OH and a COCl, so that's a possibility. This one's got a Cl and a COH. So I need to know what kind of groups will bond together in a condensation reaction. Well, I can have a carboxylic acid and an OH will form a polyester, or I could have an acyl chloride group such as this COCl with an OH, which would form a a polyester as well. Instead of it releasing water like carboxylic acid group and OH, which will release water, it will release HCl as white steamy fumes, but it will form a polyester. Or I could have had a COCl or a COH with an NH2 to form a polyamide with an amide link, but C will work.